Hello everyone, my name is Zishan and you're welcome to Zishan classes. Today we are going to look into another question from the chapter Kinematics. We are preparing for JEE and we are looking into questions from the chapter Kinematics physics subject, and we have already addressed two questions from the book Irodov, and we're going to go into another question now. The question goes like this. There is a plank of mass m1 over which there is a bar of mass m2 which is being pulled by a force F equal to AT, where A is a constant and T stands for time. This force is variable with respect to time. Now, what we have to do is to find the acceleration of the blocks A1 and A2 of the mass m1 and m2 respectively, and their relation with time, and also we have to plot graphs for this variation. The coefficient of friction is given as mu. So we'll find the accelerations and we'll plot the graphs. For such kind of a problem, you need to understand that the blocks will move together till the force F reaches a particular value, and after that the bar will start moving with an acceleration larger than the acceleration of m1. We will calculate the value of acceleration for these two bodies when they are moving with different accelerations first. So we'll draw the free body diagram of the blocks. The equation for this bar m2 is going to look like AT minus mu r equals ma m2 A2. AT minus mu times m2 g is equal to m2 A2. This implies that A2 is equal to AT minus mu m2g divided by m2. This is the acceleration of the block m2 when it is not moving with m1. I have said in the beginning that these two blocks will move together till some value of f, and after that they'll move with different accelerations. We are talking about that situation, and we have calculated the acceleration to be equal to AT minus mu m2g divided by m2 for the block m2. We'll keep this with us. We'll come to m1 is going to look like mu r equals m1a, where r was equal to m2g equals m1a, and we arrive at you note these down, and then we arrive at A1 equal to mu m2g divided by m1. So we have calculated the acceleration of both the bodies, body 2, body 1. A2 will be equal to this much, A1 will be equal to this much. Okay. Now we'll keep these two with us. So these are the two values that we required. But we also have to plot the graph of their variation with time. For that, we are going to have to find the value of t for after which these two develop different accelerations. For that, we're going to use these values only. And how? I'll tell you how. These two, A1 and A2, were same till a value of t. We are going to name that value T0. After T0 time, A1 and A2 assumed different values, which means till T0, the time T0, they had the same values. So we are going to use this concept for finding the value of T0. So we're putting the value of, we're putting T0 equals to T here, and we arrive at A T0 minus mu m2g divided by m2, which is A2 at time equals to T0, and mu m2g divided by m1, which is A1 at the time T0. Also you can see that A1 does not depend on time, it's constant. So we'll try to derive the value of T0. How are we going to do that? Cross multiply and we will arrive at, so this is the time when these bodies started to move with separate different accelerations. Also we will find the acceleration of the bodies when they were moving together. Oh, that is very simple. How? Consider them one single body. Being pulled with a force equals to 80. Now since the floor is smooth, the acceleration the friction between these two bodies doesn't matter. So 80, the force, will be equal to m1 plus m2 into A, acceleration of both the bodies together, which gives us A12 will be equal to AT divided by m1 plus m2. Again, we got another point for us which is going to help to draw the graph for these two bodies. The acceleration of these two bodies together has the value AT divided by m1 plus m2. Another important point for us to be able to draw the graph of variation of the accelerations. A12 is equal to AT divided by m1 plus m2. So we have arrived at different values of acceleration which was required. We also have calculated the time beyond which these two, A1 and A2, have different values. We have also calculated the acceleration of these two bodies together. We're going to use all these four factors to draw our graph. Our graph is going to look like acceleration on this axis, time on this axis. Both of them are going to move together till a point then one of them is going to have a constant acceleration, and then the other one is going to have an acceleration this way. What is this point going to be? This is the value of time t naught. This is where the acceleration had the value a t naught divided by m1 plus m2. This is the value of the acceleration of the mass m1, the value of which is equal to mu m2g divided by m1, and this is the value of the second block m2. This is a1. a2 is going to be equal to at minus mu m2g divided by m2. Also, this is being governed, this line is being governed by the formula at divided by m1 plus m2. And this is what the graph is going to look like.